So in addition to the product rule, to go on with our fundamentals of counting, we have a sum rule. And this is basically about breaking things down in a slightly different way. So if an object falls into one of two categories, and let's say these categories have no overlap, so it's one or the other, but not both, sort of an XOR situation. And if we count these categories, there are n1 options, n1 options in the first category, and n2 options in the second. Then there are n1 plus n2 options total. So the product rule, we were saying that if you can break an object down into two pieces, so somehow for the product rule, you're making two choices and you're making both of them for each object. For the sum rule, it's a different situation because you're saying this object falls into one of two categories, but you're only doing one at a time. So it's going to be one of these two things, but not both. That's essentially the idea of the difference. And okay, let's give another set analogy. For sets, if we have two sets which are, let's say they're finite and they're disjoint, then the cardinality of A union B is equal to the cardinality of A plus the cardinality of B. And this is saying essentially the same thing, right? Because here we have objects that are either in A or in B, and since we're assuming they're disjoint, they cannot be in both. And here we're saying that the number of objects like that is just the number of objects in A plus the number of objects in B. And again, more generally, we have an exactly similar situation with more than two things. So if we have a bunch of categories, and we can count how many things are in each category, then we just add them up to get the total. And similarly, this is just like saying that the union of some finite number of sets, which are all disjoint, is equal to the sum of the cardinality of each individual set. I guess this was an R, was it not? Very nice. So let's see some examples. Well, here is quite a simple example. Let's start off from the, from the very basics. So let's say if there are 40 students in N55 lecture 1, and there are 36 students in lecture 2, and 37 students in lecture 3, and maybe 32 students in lecture 4, how many students are in N55 total? Well, we have these 4 categories, and each thing in the whole falls into exactly one of these 4 categories. So the number of things in the whole is just the sum of the things in the categories. Which is, in this case, 145. Okay, so before we move on, let's take a little time to recall some examples that we've seen before. So here are some familiar examples. Of the sum and product rules. How many rows in a truth table for some proposition like P and Q implies R or S? We do have some space. Nice. So what is this asking? It's essentially asking how many combinations of truth values can we give to these 4 propositions? So we can analyze this in this language by saying that we can break it up into 4 pieces, which are P, Q, R, and S. And we have 2 options for each. They are either true or false. So the total number of options, the total number of combinations, each of which gets a row in our truth table, is so 4 options, and each of them, or 4 pieces, and each of them has two options it can be. So we just multiply 2 4 times. So it's 2 to the 4th to 16. So we've been doing this throughout the course. We've been saying how many of these things are there, and counting things using the product rule. But now we're being explicit about it, and we're going to build it up into more complicated things over the next couple days. Here's another one with the sum rule. So when we were counting domino tilings of a 2 by n checkerboard, and let's say that an equals the number of 2 by n tilings. Well, remember, the argument that we gave was that if you have a 2 by n board, you can split it into 2 categories. Namely, by looking at what happens on the leftmost 2 squares. So either you can have a domino that sits like this and leaves a 2 by n minus 1 board, or you can have 2 dominoes which sit like this and leave you with a 2 by n minus 2 board. And so we implicitly used the sum rule when we said that an, which is the number of 2 by n tilings, is equal to the number in this category, which is the number of 2 by n minus 1 tilings, an minus 1, plus the number in this category, which is the number of 2 by n minus 2 tilings, an minus 2. So you can see we've been doing this throughout the course, and we will continue to do it. But now we will be doing more and more complicated things as well.